don't mind. Where's the reporting?
I already did it, Ilya.
Oh, you did. Thank you. That's why we'll do it together with CT, because I keep forgetting things. All right. We have 9 people. Let's just wait for one more, and then we'll have 10, and we'll get started. You can see my screen, right? So we will talk about network analysis of transboundary groundwater researchers, co-authorship network that we developed in our project, but we will also cover some basics of how you work with this type of data and how you use the system called SuAVE. SuAVE stands for Survey Analysis via Visual Exploration. That's kind of homegrown system that we have used in multiple projects. And for this project, we added bibliographic analysis of co-authorship networks to the set of views that we already have. And we will talk through some basics of SuAVE and then move to the mechanics of developing these networks. 10 people, so let's get started. And by the way, the slides that I will be showing are available to everybody. CT just posted a link in the Google in the chat. So if you feel that you can't, you know, it will be fairly fast paced. So I'm not sure we will be able to complete all the steps together, but the slides are merely just an additional tool that we will not necessarily refer to, but it will help you remember what we covered in the demos. Okay, so let's get started. My name is Ilya Zaslavsky. I'm at San Diego Supercomputer Center and also a co-PI on the Transboundary Groundwater Resilience Project. It's one of AccelNet projects. And the announcement of this webinar has been sent to those projects that I talked, also AccelNet project that I talked with, so they talked to me. Some of these projects started on their co-authorship networks. We also participated in the network workshop that Anne and Michael organized in spring of this year. So some of you may have seen the tool, but it got better since then. And I'm here together with Christine Tang, who works for New Mexico State University and is part of the Water Resources Research Center, which is kind of the prime on this grant. So Sam is also here, who is the PI in the project. And mostly I will be talking about the mechanics of what you can do with the system. But if you are interested in specific ways of how we use this network in the project, we will also cover that. All right. We probably want to start with very brief intros. I already told about myself, plus you will hear from me for quite a long time now. Maybe CT, you will be the next, and then we will just go around the room. The idea is to make it very brief, but also figure out what you want from this meeting, and because we can certainly adjust as we go. CT?
So Ilya already introduced me. I'm also a PhD student at Worcester Polytechnic Institute. And next we can have Christopher.
Yeah, hi everybody, I'm Chris Scott. I'm on AccelNet Sustain Food, which is a US-Africa network of networks to work on water, energy, food nexus topics. And we are now starting our second formal year of the project. And just a shout out, I'm also a groundwater transboundary water buff in my other incarnation, or still my incarnation. Would you like me to call on the next person? Okay, I'm going down the list and I see Anne. Nice to see you again, Anne.
Hi, nice to see you. I'm Anne McCraney. I'm at Indiana University Bloomington, and I'm part of the multi-net AccelNet group, which is now entering, I guess it's 5th year, or I guess 4th, I'm not sure. Yeah, it's 4th. We were among the first cohorts, and our group is about theoretical and application progress in multi-level, multi-layer network science. So this is obviously a topic of interest in ours. And I've also taught a workshop on like actually doing network analysis, but love this tool. I'm very excited to see it and the changes you've made in it.
Thank you. You select the next one.
How about Abdullah?
Hi, everybody. My name is Abdullah Konak, and I'm a faculty member at Penn State Berks, and I am affiliated with the Sustain Food Network as well, or the project as well. I think Chris mentioned about that project. So our interest using this tool is actually we really want to create a authorship network, our engagement network with Sustain Food, and demonstrate that how it changed over the years. And last year, after I met with Ilya in the workshop for the CopusDB meeting in DC, I start using the tool, but we couldn't plot a network. And I realized that my account was deleted from that year, or my work was deleted. Is that correct? Or because it's the new version, I guess.
The old version should be still there, but
there?
the old
Okay.
version doesn't really support network analysis. It was a
Yeah.
hack to show that last year.
So because I uploaded some stuff there, and since I couldn't achieve my goal that time, I stopped working on it. I'm looking forward to learn the new tool. Thank you.
Yeah. We can look offline, you know, and figure out where your stuff went, but I'm pretty sure it's not lost. Okay. You select the next one. All right, then I do that. What about Susan Sang?
Okay. Sorry, I called someone.
Oh, all right, okay. I shouldn't interfere. If you are muted, yeah, I'm muted.
Yeah, sorry. Yeah, I'm attending from offsite because I'm actually basically in Chinese Thanksgiving mode right now. But hi, everybody. I'm Susan Sang. I'm a research associate at the American Museum of Natural History. I'm one of the co-PIs on the Global Bat Net, which is a network of bat networks. So right now we have a member network. We have a 18-member network of networks in our AccelNet. And we work on different aspects of bat research that range from ecology, genomics, evolution, paleontology, behavior, and disease ecology and conservation. And so we work together in order to share our resources, to basically get everybody on the same page about how to communicate with the public about bats, and then also really get people to understand each other's fields better, because we don't want siloing to happen. And basically that was the goal of our AccelNet. And from this particular tool, and I attended the early workshops with Ilya, we wanted to actually evaluate how connected we actually are as a product of us working together in the working groups and the networks that we formed under the AccelNet. So we hopefully will see a more connected group in the BAT community as a result of that, and hopefully this tool will help us demonstrate some of that.
Mm-hmm. Great. You can tap someone.
Sure. How about Johnny?
Hi, everyone. My name is Johnny Musumbo. I'm a PhD student at Michigan State University, and also I am part of the AccelNet project, System Food Africa, America, and I've been invited to this event. So I'm just curious to see what it is and how I will benefit from it.
Great. Next.
Everyone. So my name is Eddie, and I am coming from IGRAC, from the Netherlands, the International Groundwater Resource Assessment Center. I'm a groundwater specialist, and Elia, I think you may know Elizabeth. And I am here to discover the tool and see how we can use it, because I'm now involved in the transboundary map, and we want to update our map to the new 2023. So yes, let's see. And thank you for inviting us.
Annette?
Hi, I'll put my video on for the introductions. I'm also part of the Sustained Food. I'm a co-PI with Chris and Abdullah, and happy to have Johnny on board. I'm really sorry I missed the earlier webinar, but I'm excited to learn about this. We're in the process of co-authoring some papers and policy briefs coming out of year one, and it just seems very timely to learn this software.
Great. And I think we have MV. Who is MV? You can unmute yourself or even show a video. Or we can do that later. All right, let's get started. So we have a mystery guest. Anyway, the plan is to talk about the basics, to start with the basics, and I will quickly show you how you publish so-called surveys into the network, and then we'll look at how you publish co-authorship networks. And then show how you can do curation of this data. But starting with a few words about SuAVE. And by the way, you have a link to the slideshow in the chat, so you can follow all the links yourself. So SuAVE stands for Survey Analysis via Visual Exploration. I still call it a new online system, but it's probably an old slide. It's been around for some time already. And it's been used in multiple domains to show image galleries and to do analysis of art collections, to do analysis of coral reefs and a bunch of things like that. Basically, how you work with that, there is a system for publishing data where you can upload a CSV file or point your data to a Google Sheet or any other document on the web that will produce similar data, such as tabular data. And then you kind of add that new so-called survey into your survey gallery and can open that in an analysis application that allows you to do visual statistical cartographic analysis and also integrates Jupyter notebooks. You can also annotate this data, collaborate on this data. And more recently, we added a few components to that. One is integration with a survey tool called LimeSurvey, where you can author questionnaires online, similar to Qualtrics, similar to SurveyMonkey. And then once you enter information into that system, it will show up in SuAVE immediately. And this is, by the way, how we set up a system where you can answer a few questions about your network of networks and locate yourself, place yourself on the map, upload your photograph, and then it will, your information will end up in the gallery. CT will talk about that later, but mostly we will focus on how you bring in bibliographic data into the system, which comes from OpenAlex. So I should say that I did get some grief about the SuAVE name, because it's been often confused with other tools. I have quite a collection of emails like that, but we'll get to that later if there's interest. So initially it was developed as a tool for analyzing questionnaire surveys, but then the applications kind of grew in scope. We started analyzing image collections, and the main idea is to have a tool that doesn't have any learning curve. It's very easy to publish data and to use. And it can be extended with Jupyter. We also extended that with R, but R has not been used that much. Since you can take snapshots of your data at any point of use of your data, you can organize them into a story. And some of these stories I have on the website. By the way, the website is just suave.sdsc.edu. And here you can see a bunch of examples from different domains. You can see how it's been used in teaching, and it is being used in teaching several classes in urban planning, in sociology, and look at tutorials, documentation, and so on. And also look at the blogs, because this is a way to sort of tell a story where from any statement you can jump into the actual application, and I will show you how to do that. So before we kind of jump into the mechanics, we need obviously to create an account. Some of you have done that. You can go to suavenet.sdsc.edu and then specify your name, username. So that's like simple things that you can do without much direction, I hope. If you haven't done it, please do it now, because it will help later on as we actually work through the applications. You will get an email with verification code, and then you just enter verification code, and well, you are in. And once you have done that, you will see so-called gallery that will be developed for you. If you go then to suavenet.sdsc.edu, you will see that gallery. In this case, I already have a bunch of surveys. But if you just created your account, it will be initially empty. And the only thing you will see is that new survey button. If you click on that, it will open a dialog where it will ask, what will be the data that will go into your survey, and how you want to name your survey. Typically, or let's say in the simplest case, you don't need anything else just beyond the CSV file. I have one example that I want to show you that demonstrates how simple it is. So there's a survey that was done at the early stages of EarthCube. You see that this is a simple CSV file where people have been asked a bunch of questions about, what's your primary discipline, expertise, years of experience, how easy it is to work with different types of data. There were about 1,500 people in the survey and a couple hundred questions. So this is a CSV file that you can use for a system like that. So let's say demo 1, and then you point to that file, and that's it. So you don't need to do anything else. You just have a CSV file where you have records as rows, and you have variables as columns, and that's pretty much it. So you have demo 1. Of course, it will look ugly at the beginning, because when I click on it, you will see that it just uses a default symbol, but already you see all your variables listed here, and you can look at distributions by those variables. And you can do some analysis by seeing how these distributions change under different subsets. Okay. So this is what we call a survey, and survey is the main unit of this analysis, of course, of the system. Of course, you can then go to settings and make it kind of look better. Let's say you want to have additional views, you want to add Jupyter, you may want to specify that you want to have different symbols. Let's say a field to associate with shapes will be gender, and we'll look at different silhouettes here. You can add, let's say, primary discipline to specify color. You will have an additional variable that would show up as dynamic text. You can have URLs added. And once that is done, it will already look somewhat better. You see, I'm doing it very quickly because indeed it's like 20-second exercise that you can do that will already let you make some meaningful online presentations that you can share with others. The way to share it with others is just send them this URL. Okay, and there are quite a few things you can do here. So, for example, you can look at questions such as how important is atmospheric data for that group of people. You can see that you would hypothesize that for folks who are in atmospheric sciences, atmospheric data would be important. So let's subset it by atmospheric science people. And indeed, this is the highest group who say that this data is critically important, except for like one renegade who says that this data is of low importance. And the advantage of this tool is that you can simply zoom into that person and see why his responses are different. Okay, so you can kind of transcend scales on this analysis. It's a way to analyze surveys in the same way you work with Google Maps, where you can zoom into certain patterns and look at the details. So this is the very kind of elementary basic intro. And what we covered is a few key notions of that system. What is a survey? What is a survey gallery? Because you see that once I edit that survey, it showed up in my gallery. And in the same fashion as you will work with your data, you will get surveys in your gallery, which you can then delete. You can make them public or private. You can change all the settings, and the settings would include some cosmetics here, but also you would find that there's an additional field, additional tab for managing network visualizations. In this case, we're not using that. You can edit variables and specify types of variables. You may want to add metadata. This is a demo data set. Something that will that you will see then when you work, when you click on information button. This is a demo set. Yeah, so these are the main things you need to know, because everything is built kind of on that. New survey, upload new survey. You can upload CSV as the bare minimum, but in addition, you can upload images, you can upload network files, and I will show you how you can generate these network files. So another example, and by the way, you can see all of these example data sets if you go to the main website and go to tutorials. There will be a collection of sample data sets ready for publishing in SuAVE to practice. What we used is EarthCube member survey, and I will show you one additional data set, how to publish that. That will show you how you can connect images and metadata in one survey, and how to create an image gallery. So with Picasso paintings, let's look at what we have here. So here I have images that look like that. And these images can be actually very large, because we're not going to push the images themselves into the system. We will build image galleries, image pyramids, so that as you zoom in, you will get higher resolution images each time. Of course, these are not all Picasso paintings. It's just a small subset. And the CSV file, which is very similar to what the CSV file we had before, where you can see that each record will also have a field named image, and this image will refer to the image names in the set of images that we have. You should also see that it has latitude, longitude. This is some information about each painting, and how you publish that is also very simple. So you go to New Survey, create, let's say, Picasso demo. You point to this file, let's say Picasso paintings, and then say that you want to upload images. And these are the images. You just select all of them, say open, click submit, and that's pretty much it. So it's like 10-minute access, 10-second exercise to create an image gallery. So if you have photographs of, I don't know, water samples or bats or any other topic that you work with, your files have been uploaded, and I just need to wait a little bit because it converts all images into image pyramids. Eventually, it will send me an email that this is done, but maybe it is already done. Okay, yeah. So this is what we just published. And you see that as you zoom in, you get higher resolution images. You can sort them in any way you want. You can, let's say, look at that by years. You can do some interesting things, such as figure out when were different periods in Picasso's life, such as blue period. If I can show you that it's fairly easy to do. You just subset it by certain period of years, and then you will see how it looks like. So that is like the basics, and I will also show you that we have, since we have latitude, longitude, we can create a map, and with that, when I load it again, you will see that there are a few new icons that showed up. That these icons show different views of the data. So you see in this view, you can look at distribution by any variable. In this view, you can look at crosstabs, which may be not that critical for Picasso, but is useful for surveys. In this view, you can look at the data on a map. And you see these allocations of paintings. Normally, Google is the slowest part of this system. When you click on any icon, you will see that there is information that is updated on the site. You can also navigate to the image that is associated with that paint. And you can start Jupyter. And by the way, this is a way to oh, yes, the question is, what is Jupyter? So this is a very popular system that is used by data scientists all around the world to do computations in a browser using Python and, well, actually other languages as well, but mostly Python. It allows you to launch kind of a scratch pad or sort of a notebook where you can mix code and explanations. And this is actually a fairly convenient way to work with your data. So if you are interested in working with any of the surveys that I have on this system, you can simply say, geoscience surveys. You can click on, you can open that survey, and then you will see that when you click on Jupyter, there's a way to clone that. One additional way to bring data into your gallery is to clone existing surveys, and then you can work with them. Or you can select some Jupyter Hub and run your computations on that. Where it is important, let's say you have a survey that you want to do some additional analysis of, such as compute derivative measurements or convert binary variables into multiple response variables, or do some machine learning, then you would simply launch notebooks that would do that. And then the data will be returned into the survey. So here we let's have a map of points, but in the same fashion, you can have maps that show associated polygons or polylines, and there are some examples online as well. So, for example, if you are working on SDGs, you may be interested in this section, SuAVE for international projects. Let's see. This is an example of how you can build SuAVE with data that refer to polygons. And yeah, by the way, you can look at distributions, but as you look at the map, you will see that you can also develop corpus maps for anything that, for any variable that you want. So this is basic capabilities that I wanted to show you before we actually start on the network analysis. Just to recap, this is how you can customize things, and there are multiple views that you can turn on. You can also bring in optionally additional map data. You can specify whether dynamic text should show up over your tiles, and there are a bunch of tabs that allow you to do some additional customizations. So what you have in a typical view, you have questions, you can search for variables, you can switch between views. There are a few additional icons that allow you to look at metadata and do data sharing. For this application that we're going to talk about, we added basically an additional view that deals with network analysis. And now I want to, so you will see a network like that, and you will also be able to look at all publications of everybody who happen to be part of this network. You can also look at some network characteristics of each node, such as degree of centrality of that node, key player fragmentation, and some clustering indexes, which give you information about how important or how central a specific person is to that co-authorship network, or what will happen if that person is not on the network. You can also look at evolution. So these are the new views, and instead of just showing you pictures, I will get into an application and we'll talk about transboundary groundwater. So this is the project that we have funded under AccelNet, where the goal is to look at groundwater depletion around the world and see how infusion of data science and simulation modeling can help with bringing different networks together and enable better science at the intersection of hydrology and data science and simulation modeling. So we built two applications, and you will have, you can just open these links. Let's say the first one is something that you get by default when you work with your when you generate this from OpenAlex search. So here, yes, you can look at distribution by, say, by countries. You can specify which countries you want to look at. Let's say those that have the highest number of researchers working on transboundary groundwater. You can, as you zoom into individual people, you can see information that comes from OpenAlex. OpenAlex is a bibliographic system that from which we generate this data. That includes name, affiliation, location, some additional keywords that we have assigned, and information about publications. So for that person, we probably can click and get the publication data. There's one relevant publication for which there is an abstract, and in most cases you can get to the actual data, to the actual publications. Okay. By the way, I'm kind of talking fast, but you feel free to unmute and stop me and make me do it slower and ask questions, okay? Because yeah, that would be better for my sanity as well. But the most yeah, okay, go ahead.
Yeah, I just want to point out sometimes the data is missing for some people, like affiliation, latitude, longitude, location. So if that happens, they won't show up on the map, and that's why there's no actual flag for some people, and you would have to have some intern or somebody like me who would go find them. I did that for a smaller data set. I didn't do it for this bigger data set.
Yeah, we will get to that in a minute, because we will, when we talk about curation, that's the usual problem, that bibliographic data sets, none of them are perfect. They all have missing data, and kind of the big difference is if they provide enough information to deal with that, to curate this, these deficiencies or not. So another version of this data, of this data set, is actually with pictures of people. And if we have time towards the end, I will show you how you can get such photographs retrieved from the web. We have some tools that allow you to search for images of not just by name, but we can introduce some additional characteristics that we search on. Of course, it is not always 100% accurate, because if your name happens to be, if you happen to have some sportsman namesake, then it's too bad. So, for example, here we can look at distribution by, as I said, by countries, by any of the other things, by H index, and by citedness and number of collaborators, and see who are like the most well-connected people in this group, and look at their.
I have a question here.
Yeah. Mm-hmm.
You created this data set directly from the citation records, or there is like a process involved that you have to take those records and create the network and upload it here?
We will get through that actually in exhaustive detail. It's just the next step.
Okay, yeah, sorry.
But before we go there, I just wanted to show you how you may use that. So you can subset here by pictures, but you can see where these people are on the map. You can, but probably the most interesting part is to look at the network. And here's the entire network that is built from co-authorship data. Let's say we're looking at, let's look at some countries that we're interested in. Let's see. Oh, doesn't matter. So we can dynamically subset this network. We can also look at specific topics that people may be writing about. So what we can do in this system, we can search by specific keywords, and you can have any number of keywords. Let's say people who are looking at, let's say, modeling. So this is a subset of the network, and you can point your cursor to any of the folks and see this is, for example, this is Sharon Magdal, who built quite a school in Arizona, I believe. She's in Arizona, right? And we can see her network and her information about her kind of network characteristics, such as centrality, centrality, clustering, and fragmentation. By the way, for each of these parameters, you can get an explanation of what that parameter stands for. So betweenness is basically the number of shortest paths that have to go through that person, right? Prestige score is similar to Google's PageRank. That's how Google ranks pages for display on Google search results. For clustering, yeah, you can look it up. And we can see how that network developed over time. So initially, there wasn't much on modeling going on, but you can see that there started to appear additional nodes in the network, and they started to get closer together, right? So some clusters started to get more connected than before. That's how you can analyze the evolution of the network and also see perhaps which topics started to gain importance. I will show you, so let me get back to the slides, just so that I remember some of the points that I wrote here. So you can do this analysis by keywords such as modeling. You can come up with any number of keywords. Search and subsets, view network evolution, compute network characteristics, and yes, another thing that that I haven't shown you. Let's say we're looking at a specific network. Those people who are looking at monitoring, and we can symbolize folks based on different bibliographic characteristics that they have. So you see the size here would reflect number of collaborators, or it can reflect citedness over the last 2 years, I believe, H index, and so. In addition, for any of these people, we can say, okay, we found, say, Sharon Magdal. We want to see her papers that are relevant to this topic of transboundary aquifers. Let's switch to the view where we can find Sharon. So let's look. Let's quickly look it up. Because I'm not sure why it doesn't show. Okay, that's her. And you see that for her, we can see, or actually for anybody, we can look at publications that are specifically focused on transboundary work. And for each of them, there will be an abstract. And there is also a way to get to the papers themselves. Any questions before we jump into how you actually build this network?
I have a quick question.
Yes.
If you're pulling the affiliation data to get the location from papers, what if somebody has multiple affiliations? Does it duplicate that in the system, or is it just going to assign it to the first one for that person?
So I tried to use the most recent affiliation, because this is something that would show up in curation, and we will look at that when we do curation. So when you analyze this network, you will see that with transboundaries, the fragmentation is relatively high. It decreases rather slowly. You can see what key subtopics are. What is the percentage of people who work on specific topics. So for example, machine learning and AI, only 1% of the authors mentioned that. So that's definitely an area of growth. Another thing that you can see here is that we also included which aquifers are studied by these people. That's also something that we extract from abstracts and titles of the papers. And it's just another type of keyword. You can have any user-defined keywords, those that we have listed here, such as sustainability, recharge, discharge, and so on, climate change, so that you can find papers that mention that. But you can also find all papers that, let's say, focused on Lake Chad Basin. And you can see where these people are in the world who work on this topic. This is actually one very recent example. You may have heard of ImpressU solicitation, or actually DCL, from NSF, where they ask for projects that will focus on Ukraine, but also work with several other countries, including Poland, Latvia, Lithuania, and Estonia. So we use the system to, well, first of all, how would you do that? And this is actually the process I went through myself. Let's look at Ukraine. And we will look at everybody in Ukraine who works with, sorry, I'm looking at the network. At everybody who works with countries that are also listed in the solicitation. So you immediately see that, these flags of yellow and blue, that's Ukraine. But this is, for example, Poland. And this appears to be the main cluster of Polish-Ukrainian collaboration on transboundary groundwater. There's also another one, but it's smaller. So what I did, I just emailed the person who is at the center of this cluster, Tatiana SuAVE, and we had a conversation, and she also involved another person from that group, and we talked with Ukrainians. And then if you start looking at this somewhat larger picture, let's bring in other countries. So Poland, Latvia, Lithuania, and Estonia. You see some interesting pattern that it's in this network, there are two clusters that kind of dominate the entire landscape. Most of the papers most of the work happens within these two clusters. There's a single person who actually connects them. So when Tatiana and Maggie and I started looking at this network, we immediately asked who that is, and the answer was, well, yes, of course, we know him. He's a very good but very busy person. He kind of knows everybody. So obviously, when you're trying to build a network of networks, you better connect with this guy. He actually joined. So Andres Morandi is this person who happens to have a very high level of betweenness centrality and also high value on key player fragmentation. And once you connect with people like that in your network, then it's much easier to build meaningful projects and kind of connect to everybody else in the domain that and in the country that you want to work with. Andres, you didn't have a chance to introduce yourself, by the way. So Andres,
Yes.
I met
Yeah.
last week.
Hello, everyone. Sorry, I was the MV at the beginning, but my Zoom just made some, I don't know, updates and everything. I didn't realize it was me, and I had some troubles. So yeah, I've been listening most of your talk.
Okay.
Thanks.
So you see that this is, and that's by the way how we have these 5 countries with researchers that we kind of see here. When we look at Ukraine, we actually also browsed some names and found that some of these folks are on the front lines. They no longer do hydrology, but they actually are in the army. And you know, this type of conversations kind of bring it very close to home when you can relate pictures that you get of the web and when you get through formal analysis with real like lives that people have in these difficult circumstances. So that's an example of what we've been doing very recently, and this is where this type of analysis really helps. Now let's try, how you can use it, explore the entire landscape, look at dynamics, look at what are the most recent topics that show up, for which there is very few. There are very few papers, but they only appear in recent years. You can look at the centrality and emergence of specific players, and if your project is trying to build a network, you can see if you have invested in the right people, basically, and see if their role in the network is growing. So that would points to an objective measure of the impacts of your project. Okay, now let's try to construct a network like that. And there is an application called CorpusDB that we built specifically for that, corpusdb.sdsc.edu. Once you created your account, you can log in with that same account. And it will give you 2 options: searching for the authors and building a network this way, or curating the application that you have already developed. So when you click search, let's say, and in this case, I'm not going to show you how we build transboundary network. I will show you something that is totally, well, it's actually related to our project, but it's a different one. Let's get back to here. This is a project that deals with offshore groundwater repositories. So in our case, we're looking at transboundary groundwater. This is groundwater that is offshore, but possibly some issues of international negotiations that we have to deal with, and analysis of these aquifers are similar. So there's a European project called OffSource, and we will just search for this data. It's called offshore freshened groundwater. Let's search for offshore and freshened and groundwater. This specifies that I am not necessarily looking for an exact expression, offshore fresh and groundwater, but any papers or titles where these words would appear in any order. And then you can also think of that groundwater may be referred to in multiple ways. It can be not only groundwater, but also aquifer, or maybe aquifers, freshened, in some case, would be called simply fresh. Okay. What I've done here, I set up a set of synonyms and the search expression. I can also use some keywords to exclude papers from what I specified here. For example, when I was looking for research that focuses on convergence research, but there's also network convergence research, which is different from what NSF thinks about convergence research. So I would exclude that. Then let's give it a name. Let's say offshore fresh and groundwater demo. That's the project name. Let's figure out what would be an additional keywords that we would use to characterize that domain. Basically, what will happen is we parse the papers out of OpenAlex, and for each, we will tag each of the papers with the additional keywords that we develop. I have no idea actually what these keywords may be, so I would ask Claude. Oh, not Claude.
There was a comment in the chat from Andres that offshore can also be submarine.
Absolutely, absolutely. So, absolutely. Absolutely. Let's say lists, let's say 40 keywords for groundwater. Okay. So we have 40 keywords. Let's actually, I want them in a list. Okay. Give it to me 1 keyword per line. Of course, this is not the ultimate way of figuring out keywords for your domain. I would suggest you actually do it in a more meaningful way within your project. So, but for now, that will do. And you can also specify synonyms here as well. There are a few additional things that you can add here, such as limit this to specific institutions or specific, range of years. But for now, I'm not going to do that. Just click run. The query is running. And eventually, you will get an email.
Can you go back? I'm sorry, I missed that step. I mean,
yeah.
Where did you put the keywords? Oh, okay. Yeah.
There's keywords here. And there is actually a help and search tips that's, helps you somewhat. Okay. What we have now is an email. Your search is done. Now, it is absolutely not a given that your search will be as fast as I'm showing here. because it all depends on how you formulate the query. If you start with a very common word in the search, it will take much longer. And also, I'm taking advantage of the cache results on my previous request. So what it says.
Can I ask a question there?
Yep.
So you have actually the institutions.
Yep.
You know, in the search.
Right.
So when you enter it, it limits the institutions. Or...
Yes, it will limit to specific institutions.
But you know, there is sometimes like multiple representation of the institutions, like Penn State, you know, Pennsylvania State University, but you know,
you see that it will give you options.
Options. Okay. So if you include all of them, it will give you all of them, or how you do that?
In the application that we have, I have to admit that the application that we have now only, and that is in a different domain from transboundary groundwater. We were asked to do this for University of California, so we had some very specific institutions that we looked at. If you want to have multiple, I would say that we will need to make some better UI for that.
Yeah. So we should not use it, basically.
But see, we just loaded all institutions. You know, there's a list of institutions that we got hold of. Just loaded here. So if you want to, load Penn State, you probably can select multiple of them.
Okay, thank you.
All right, but what I'm saying is that now we have, we got this email, and there's a code, and there is a link where you simply enter the codes and download the data. Okay, the file that you got is looks like that. It's in my download folder, and if you look, it's a zip file. If you look inside, it has a list of publications that happen to be happen to be found on that search request, the list of authors with their characteristics, and the JSON network file. So we don't even need to parse out this data, these files from the archive. We just go to our SuAVE.net. Let's see, where was that? Yeah, to our gallery, and say new survey. Let's say that's OGF demo. No, OFG, right? OFG. Upload CorpusDB zip file, and that's where we go to downloads. That's the one we just received, and you're done. So let's see what happened. We have everybody characterized by their icon, their country flags, and also you have a network view that shows how these people are connected with each other. See, compared to transboundary groundwater, this is much more connected community, because they're not as focused on their individual aquifers. They work together because these aquifers are all offshore, I guess, and that kind of methodological unity is probably more important in this case. The keywords that we specified are here, so we can look at those authors who focused, let's say, on nutrients, and see how that focus on nutrients developed over time. Okay, there was actually not much even 20 years ago, but then it started to grow. we can see, yeah, we can symbolize it in various different ways. You can look at distribution by countries, and for any person here, you can hopefully, you know, I don't know what exactly will come out, but you see that this paper looked at that offshore semi-closed marginal sea impact, and you can get to the papers. So you see that it's quite a lot more than just network analysis. You can analyze your data in multiple different ways. Now we can also customize that view, and let's say we want to show map and table and list and Jupyter, and in that case you already know that we will get a few additional views, and they will show up here. So we can see where these people are who are working on specific topics and within that overall scope. Questions? I hope it doesn't sound too difficult to develop these things, but there are caveats.
Yeah, I mean, on the contrary, I think it really straightened the process. I mean, because I tried to do this for web, and I had to download from Web of Science and transfer it to a different program to create the network, and from that program create the network file, transfer it to a different program. So I'm looking forward to use it. Yeah, thank you.
Wonderful. So the next thing, how we can improve that. So we have the network, but this network is not perfect. Why it's not perfect? If you sort these by quantity, you will see that some people actually appear in that network as more than one node. So some Aaron McAuliffe appears as 7 nodes, because what happens is OpenAlex, when it indexes publications, sometimes that person may come up with different affiliations, or it may this name may show up in technical reports or in journal publications or in some other gray literature, and there will be different IDs that the system assigns to them. So obviously we don't want to have that person have 7 nodes in our network. It should be just a single node, and this is where you need to do some curation. I should say that this problem is common for all bibliographic data sets. The difference is that we have a way to solve that, and I don't think others do. So let's go back to this. So what we've done, we worked through that screen, and we we specified thematic scope, we specified keywords, possibly with synonyms, and we produced a network view. That was done over OpenAlex. OpenAlex is one of recently released bibliographic databases. It is being actively developed, unfortunately, with lots of breaking changes. So in July, they had a major breaking change. Now they are going through the process of replacing author IDs. Ultimately, that all makes the system somewhat better because they do a lot of curation on their side, but it also have us chasing that system. We, spend a lot of time on chasing the API changes. It inherits from Microsoft Academic Graph. So it comes already as a graph, and it also included a bunch of other sources, Crossref, Workits, and Paywall, and others. And the biggest advantage is if you try to use Web of Science, your university has to subscribe to that, and if you want to use it via an API, it's actually quite expensive. We tried to do that for one of the projects and decided not to do that. It was like the level of 40,000 per year. Here we have it all absolutely free, and we can get snapshots. Actually, we set up a system where we grab snapshots about monthly from OpenAlex and set them up at SDSC so that we have kind of consistent reference point. When you send a new query, you will get exactly the same set of authors if the query did not change. So for example, when you want to search for keywords and then for keywords that reflect transboundary aquifers, you essentially run it twice with the same scope, but with different set of keywords. And then you just merge the results because they are assured to be identical because that's what we provide. So the next thing, we have published now this network. Where is it? It's here on SuAVE demos and called OFG demos. We will then go again to CorpusDB. By the way, one additional thing. And that was prompted by Michael Witt when he asked if we can just take a list of authors and build a network for that. So the answer is yes, we have an additional mode called author list. And as one of example, if you have just a list of people and you want to see how they're connected with each other, rather than do semantic search, you can do it by sorry, what is it? Just grabbing that list and taking OpenAlex IDs, pasting them in here. So GDemo, it's actually not a GDemo, that's ClassNet. I'm sure Anne would know more about that. Basically, we just pasted author IDs, and let's say we also can include collaborations within the author's institution because that's a multi-institution project, and it would be important to see how each institution is represented rather than just individual people. Click submit, and then you will get the results in your registered email, hopefully in a second. Yeah, okay, now it came, the same process. We grab that URL, go to paste it into result retrieval, download. That's the file that we got. Okay, so that's a new result of CorpusDB. And click new survey, click, so that would be ClassNet. Upload CorpusDB zip file. Yeah, that's the most recent one. And again, you're done. So now you can navigate the network, but as I said, this network not only includes people who've been listed, but also everybody in their institutions with whom they collaborate, which is just one of the options.
I have a question here. Is that possible for this network to export some network metrics for the whole networks?
Yes. So that is done in the Jupyter part. We have,
Jupyter, yeah.
Yes, we just it's not yet published, but the notebook works. I have a student working on that. Actually worked on that because it's done. It loads that into NetworkX, and then from that NetworkX you can export any way you want.
Okay, I see.
And by the way, in NetworkX you can compute any number of indices of network is just one-liners from that on. Okay. So next part, and which is very important, is curation. So we go to CorpusDB again. I can open another one. CorpusDB. I published this under SuAVE demos, so I log in as SuAVE demos and do curation. And now I'm looking for what was it called? OFG demos, right? So I'm looking for OFG demos. That's the data set, and now I open this in the curator. There are multiple ways of curating things. Of course, we can use it in conjunction with OpenRefine, for example, which is system that originated from Google that allows you to unify things. But in our case, we are not just unifying similar records. We are merging, we are also merging the nodes in the network. So OpenRefine does not quite do everything we need here. So let's see, remove non-latent people, find duplicate names. Let's see that Aaron shows up as multiple nodes in the network, and we want to say, let's see, he's shown at in Kiel in Germany, but also in Malta. In Malta, his publications from 2023. So I would actually use that as the target. So I set up a target, and when I click merge, his records will be merged into one node. Next, another guy, he is actually consistent, so it doesn't really matter which we set it to. Next guy, you see that two of the records are good, and another record is probably where he was part of a technical report, and this record did not have his affiliation recorded. So we don't want to use, let's say, merge it to the first one. And so you kind of go through that and eventually save the results. And the results will be the same set of files underscore curated, which you can load into SuAVE in the same fashion. When you do fuzzy match, you can also match things such as where you have Aaron Mikalev and A. Mikalev, right? So it's try to do kind of intelligent intelligent searching, intelligent merging in a way. I've done that before, and if you look at my gallery, by the way, you see that I make all my surveys public. So if you want to look at my gallery, or if you want to expose your gallery, you can do it in this way. Where is it? Okay. So you just go to suave-net.sdc.edu/gallery/SuAVE demos. And this is a public view of the gallery unless you make some of the surveys explicitly private, and then they will not show up here. you see that this is one that we published. This is the one that we published today. That's what we published today. That's what we published today. This is something, these surveys are those that I've done yesterday at different stages of curation. So this was a survey of offshore fresh and groundwater that was before curation, had 764 people. Returned, you see that adding submarine actually added quite a few folks, right? Because that's what we get in the most recent one. If we go to okay, that was after the duplicates have merged, and we had like 675, quite reduced. In this case already, you will see that there are no authors who have more than one entry, right? They all have a single node. But still, after duplicates merged, we still have situations like Aaron Mikhailov and A. Mikhailov. And that is merged on the fuzzy merge screen. So this is, they have it. Yeah. So if you can do fuzzy match names, it will find these types of things. For example, A. Back and Aaron T. Back. You would, in this case, it's actually entirely not clear if that is the same person, right? Because one is shown in Tel Aviv and another is shown in Philadelphia. But for that case, you may want to see when these people were active, if it's indeed the same person, and see if the concepts are similar, if the publications or keywords are kind of matching, and use that to help you merge. Or A.E. Mulligan versus N.E. Mulligan from the same place, definitely the same person, right? So in that case, you simply say, let's make a more complete name. So that's the target, and select them all and merge. Now it will be all merged. Does it make sense? And do you have questions about how to do curation?
How long these files will be stored? I mean, is that how long we can keep them, like the search results? And
so as soon as you retrieve the search, so when you retrieve the search results through, that retrieval mechanism, it will be deleted from the server. But supposedly when you download this here, it will be removed from the server right away. But
right.
Your surveys will stay there in perpetuity, I guess.
Yeah.
I mean, as long as I don't have to shut down the lights, right? Then they're here. Well, which is, of course, obviously we need to prepare for that. But for now, I have somewhat secured enough storage, and the network files themselves are not very large. When it gets pretty big is image collections. And for that, I have a disclaimer, sort of, let us know if you want to publish a lot of images, because currently we work with our library and they allow us to publish as much as we want, but, I don't want to abuse that privilege. Okay, getting back to the demo. So you can basically specify merge targets. You can have multiple modes of curation. You can also click on any record and edit these records individually. And I also suggest to use OpenRefine as part of the process. It will not do the node merging, but it will allow you, it will have more fuzzy match algorithms than what we have included here. Once you save it, you get the file that you can add as a new survey kind of immediately. Now, we have documentation. Documentation has been written as a disclaimer. It has been written by a student, and I never had a chance yet to kind of read through that carefully, but it does describe the main workflows and talks a lot about how you work with. So if you wanted to publish raw survey data, click here. If you want to launch Jupyter Notebooks, click here. So basically all the key workflows are described here. And if you want to look at working with OpenAlex, look at SuAVE bibliographic network section and data generation and filtering using CorpusDB. So chances are you will find some deficiencies. Let me know. So another thing I mentioned, that you can actually add additional spatial layers to your map. So that is very easy to do as well. In case of transboundary aquifers, I had that shown on a map. You see that can zoom into these aquifers, and it will give you information about the name of the aquifer, the countries it covers, and so on. You can do exactly same with any other data. For that OGF, or sorry, OFG, I went to that Zenodo website where you can grab an Excel file with information about the offshore fresh and groundwater places that have been discovered so far. And once you download that, you can simply say my maps, Google, right? That will allow you to open Google My Maps. Let's say create a new map. You would need to import that CSV file. And I have that CSV file downloaded and cleaned up just a little bit. Basically, they had headers on 2 rows, and here you can only have a header on 1 row. So let's see. So I would drag that here. And then it says location. So latitude is latitude, longitude is longitude. Site name would be the name. Then you say, okay, we have these things. You can modify them. You customize the styles. Doesn't matter. So whatever, map. Let's say anyone with the link can view and preview, and then you have this URL that you simply go to your SuAVE application, OFG demos, right? And add this to overlay. That's it. So in this fashion, you can add as many layers as you want. So now it should show on the map. Oh, of course, I should probably spend time on customizing this thing and making it look better. But these are the recorded locations of offshore groundwater. So for any of them, I can get the complete information that came in that CSV file, which is probably, again, an overkill for most cases. So that's yet another function that you have that is, I hope, easy to use. And finally, we have a few more minutes. Comparison with Web of Science and a popular system called VOS Viewer that is available from University of Leiden, and it's been quite widely used. So we get a lot more, about 33% more on relaxed queries and 61% more, at least in the case of transboundary groundwater, on strict queries. Relaxed, I mean, terms can appear anywhere in titles or abstracts, and here they're expected to appear in this exact combination. I think we have a better way to specify our queries because we can do synonyms in a much more efficient way, and they claim that they index the entire papers. We only index abstracts and titles, and still we get more, probably because Web of Science doesn't go that far into technical reports. And in our field, we need to work with technical reports. As to data quality, that's a snapshot of transboundary groundwater results that I got from Web of Science. You see that these exact problems of the same person having multiple entries and shown as multiple nodes appear here as well. It's just the first page, and there are 3 at least. The problem with Web of Science is that not only that they may have multiple IDs for the same author, but in some cases they will have no ID at all assigned for an author. And that makes it a lot more difficult to develop any curation methods over it. In our case, OpenAlex is very generous assigning more than one ID, but at least everybody get an ID, and so you can work more consistently with the data. Questions so far? Because now I want to show you one additional functionality, probably the last one. Also, I have 2 more demos, 3 more demos after that. But I want to stop just for a minute to grab something to drink. I was really worried that I wouldn't be able to speak because I caught a bug on the flight from Cape Town. And anyway, so questions? If not, I'll show you one additional functionality. So this is how we started building a network. We started with a survey that we put up online, and here you can, and by the way, if you are interested in transboundary groundwater, you can participate in that survey as well, and actually you're very welcome to do that. There's simple capture, which turned out to be a deterrent to some people. So you have a survey that knows about you because I entered my own token. You can request a token by just entering that survey without your personal token. In that case, it will ask you to submit your email address, and we'll send the token your way. So basically what happens here is that you can say whether you are responding as an individual, institution, or network. It will reformulate the questions. Here you can place yourself on the map. You can upload your picture. and answer questions about your projects and about your interest and so on. Once you click submit, then it will immediately go into SuAVE, and your record will be added here. And then we can also build sort of simple networks, but these networks that you can build here are not really that interesting because they are just in another view of CSV file. So for example, how people would connect based on, I don't know, the sector they represent. It kind of looks like a network, but, and you can see how each person is connected to other based on which factors, but it's not really very useful. This entire system was set up by CT, and if you are interested, we can actually walk you through how you set this up. Shall we do that, or shall we listen to your questions?
I think this could be very helpful. I mean, so basically, you know, you're just gonna record everyone who involved with your network or with your project. Is that the idea?
That's the idea.
So right now, what we are trying to do is like, you know, actually, I was about to send a survey for like this week. So like kind of egocentric survey. So we have the list of the people who attended our event so far. And when we were going to ask them, you know, what are their institutions and which institutions they work with. Okay. And then from there, we were trying to create a network map this year, and we will do the same thing next year, and we will do the same thing in third year, and trying to show how, you know, our project actually, you know, help to develop those relationships. So I wonder if people will be willing to use this system to enter their data and create their network. How that would be implemented here?
The easiest way would be if I can get you an account on our LimeSurvey, and then CT and I will show you how to configure translation of survey variables into SuAVE variables. And that is pretty straightforward.
Yeah.
It's just a Google Sheet that includes the mappings, and then immediately after you submit, you can show this URL, and this the gallery will include the person who submitted the data. What we found, though, is that it's very difficult to get good response rate. You have to bug people to enter information.
Yeah, I'm good at that.
Okay, good.
I mean, because right now we have like more than 500 people, you know, attended our events. You know, we just want to display them on the on some kind of website too. I think this could be a very good way of doing that. You know.
Okay.
And the next slide has the links to help you do that, actually.
Okay, it's great.
Yeah, so LimeSurvey is actually a very good system. It's open source. You can install it on your machines. It is an alternative to Qualtrics, which is, of course, very expensive. So many universities use LimeSurvey, and we just made a bridge between LimeSurvey and SuAVE, so they talk kind of seamlessly.
I also
Go ahead.
So that last link is a template of the survey that you saw that Ilya demoed. Yeah, and feel free to edit that as you wish and use it. And we can also make a copy of what we have on LimeSurvey, so you can see the code behind what we did, so you don't have to recode everything by yourself.
Right, and do you have a link to the mappings file here?
The mappings file?
Oh, remember the mappings Google Sheet?
Yes, I know. I just didn't know the Should
Yeah.
we share that with other people, like the one specifically for TGR?
Yeah,
Okay,
well,
sure.
yeah, in this group, we probably can share. But basically, the idea is that well, we have a Flask application that reads, that listens to LimeSurvey when it submits, and then connects to a Google Sheet where you specify the mappings between LimeSurvey variables and SuAVE variables, and automatically updates SuAVE.
And then the equations that you show for the Google Sheet.
Mm-hmm.
Yeah, okay.
Yeah. So how you configure it with a Google Sheet, it's quite easy. So if you go to, let's say, where did we have it? All right, I'll start a new one.
Ilya, I can share. Oh wait, never
Oh,
mind.
yeah.
No, you can. Never mind.
Share your screen then.
Well, I wasn't going to do that. I was going to share the sheet that you wanted me to show.
Okay. All right. I'll share my screen then.
Okay.
So tell me what's going on. Are you sharing or am I?
Oh, I thought you said you wanted to. Sorry.
All right. Okay. I'll be sharing. So you have a link, right?
The spreadsheet?
Yeah. So yes. So this is just a Google Sheet that says that this SuAVE variable, like image, should come from a question about image. Type should come from a dictionary question, and it should be mapped this way. And so it's fairly simple.
Yeah, I see.
And that's the only thing you will need to do. And it's all kind of documented, I'm pretty sure. For most types of the questions that you will need. So just a summary. What we have with SuAVE is not just a network analysis system, but a more complete visual and analytics system where you can browse images and work with data, launch Jupyter notebooks. There are multiple data views, and just one additional view that we happened to add here is based on bibliographic data. So it has lots of capabilities beyond network analysis. It's kind of specifically tuned to worldwide co-authorship analysis, so something that would be useful for AccelNet projects. And so we use flags as the default, but we obviously can replace them with photos or some logos of projects or whatever you can come up with. No other network analysis system, as far as I know, allows you to add user-defined keywords, and we have multiple sets of user-defined keywords, such as those that I generated with the help of Claude, or those that came from YGRAC as the names of aquifers. You can also do some additional filters. You can do filtering and subsetting on any of the concepts. You can look at network evolution. Again, this is something that other systems do not support, as far as I know. I believe only one system of network analysis package that we looked at allows you to easily compute indexes, but in our case, it's just shift-click and you get information about the role of each particular node under any subset. So you can see whether the node of that person changed within the world network or within the specific country or within specific subdomain. access to abstracts and papers, integration with Jupyter. I haven't talked about ability to annotate and share data views, but that's also very simple. So let's see if you have a view that where you're looking, let's say, at people who work on modeling in Mexico, and you want to save that network view and share with others. You just say share, you get this URL, and you can put it in email, you can put it on Facebook, whatever, and then your collaborators on the other side will be able to see that same view. And that applies to yeah. Okay, see, we will have that same view. So when you write a blog, when you tell a story, you can create a story such that from each statement you can actually jump into a specific view. And again, I'm not sure any other, other systems do that. So for the same, you can get, if you want to share a specific individual, such as we can do annotation as well. So let's say this is person who wants to connect with, right? You can add this annotation, and this annotation will be available to your collaborators. So we can save this view again, and you will be able to share it with your notes to whoever you work with. Okay. All right, so that's what we shared, and this is what we got to, right? So you can annotate and share data views. You can export subsets of the data. So if, for example, if you're interested in just exporting this subset of people, you just click Save Subset as CSV file. This is the upper level of icons that allow you to do these additional things. So there's a set of views and a set of additional operations that you can use. Normally, I also paste in information that I get from CorpusDB because that allows me to reconstruct how this network has been built, with what scope, with what keywords, and so on. And that is available by clicking on the eye. There are some additional settings, but don't worry about that. So after that, and I know that I'm running out of time, I would have two questions, because when we did the initial poll, October 3rd came out as the next most popular date. And I kind of blocked that time for a potential follow-up meeting. If you are interested in that, let me know. And also what specific topics you would want covered. And if you just want to spend the time to work with me and with CT on your experiences with the system. I will not be at the annual meeting. I will be in Japan, but CT will be there. And if you want to prepare any of the networks for your domains for that meeting, I can help you while I'm in town. So, but also some advance notice would be nice, so that I, set aside some time.
Are you going to send an email or?
I will send an email, but also you know how to reach me. So just send an email to me if you want that October 3rd meeting. Okay.
So Ilya, is there already a slot that you proposed for that annual meeting, or is it not like that?
Yeah, CT is given an update, right?
Yes, I believe I have 7 minutes or something like that. But I
no
think
workshop
people,
or round table or anything like that at the annual meeting.
Well, of course, 7 minutes would not replace 2 hours that we spent here.
yeah, yes.
And also, this meeting today was advertised only to a small subset of projects. So if you feel others would benefit from that, we certainly can make it broader. I just didn't want to make the audience too large because chances are we will need to work through specific applications with you.
Yeah. So I just wanted to have a clarification. When you talk about your experience, is it about the project or personal experience with dealing with the?
No. I would assume that between now and October 3rd, you would try to do something with the system, and chances are you will run into some blocks, and this is what we can resolve together on October 3rd.
Thank you.
Yeah, so not I mean, not overall experiences, obviously, but just if you tried something and that didn't work, we can discuss it then, or just email me. One last thing that I wanted to show, and this is actually opens up the possibilities of what you can do with the system dramatically, is let's say I would go to a private window because I have too many accounts on UCSD machines, and I will show you how it is possible and actually quite easy to work with Jupyter notebooks. Okay. So let's see. I will go to that same tiny URL. .com/tgr let's say plots. That opens the application, and I will now click on Jupyter, and will connect to one of the hubs. We have Google Colab almost working, so it will be available to everybody. UCSD Data Hub obviously is accessible to UCSD folks. So small demos. That's your account. So connect to UCSD Data Hub. It will ask me for a username. Let's see. Reader. So I'll select one of my classes. So let's say this one. not very fast. Okay. That's not something I have control of, obviously. What? All right. Okay. So that's something I'll show you later, I guess.
Well, I tried one of the notebooks. It opened for me.
Okay, good. In what? In my binder or in
the second data hub?
Okay. All right. Good. It's just I don't really remember which account works with which and where I have it installed. Sorry about that. I guess that's something that I can work through later. But basically, what you get is you get the URL survey parameters sent directly to the notebook, so you don't need to type in anything. You just click through cells and eventually get to the menu of operations. One of them will be, hopefully by October 3rd, will be network X analysis. On that note, we're 2 minutes short of 2 hours, and I've talked too much.
I really appreciate your time. It's pretty powerful.
Thank you.
Thank you very much. I think we will, I will definitely try to use it, but I'm not sure I can do it by October 3rd. I'm leaving for a conference. But that feature that you show survey is kind of interesting for us.
Yeah, that's actually very easy. And I also have a student who does it routinely now for UCSD classes, because this is how students submit their work in some classes.
Do we have to have a special account for that to connecting survey, or?
Well, because we have to connect it with our Flask server, it has to, we use LimeSurvey that is installed on our machine. But I can give you an account.
Okay, thank you.
Not a problem.
Thank you very much for your time, and this is very.
Yeah, thank you very much for attending that. Hope you spread the good word, because I'm not going to be at the meeting. And let's work together. Bye-bye.
Thank you very much.
Thank you.
Thank you. Bye-bye.
Great stuff.
Okay. Thank you. I was worried about my voice because I caught a bug, but yeah,